Let's discuss a new concept which is a DFS graph. In graph theory and computer science, there are various types of traversals, and how do we structure the data. According to that, the graph theories come into picture. So there are two principles in graph theory, that is DFS and BFS. So in this video particularly, we discuss the DFS graph, that is depth first search. In depth first search, what happened, as if we consider a tree, and the tree have some elements in root and leaves and internal nodes also. In that case, when we iteratively go through that tree, then we have to consider the one principle, that is LIFO, that is last in first out. For example, as you see on a screen, there is one I drawed here, one stack, that is 5429. The top of stack is 5, and as we go through the stack, at each and every time the top will be printed. So 5 will be printed, after that 4 will be printed, then 2 will be printed, then 9 will be printed. So DFS graph basically works on a principle of last in first out, that is LIFO, and it uses a data structure, that is a stack. So these two fundamental things we have to consider in our mind when we want to write a code on a DFS graph. So there are so many questions like why we would require a DFS graph. Like in web search engine also, in traversal problem also, we require DFS graph, because when we want something to go through the route and then back traversing and then go into the neighboring nodes, then we require a DFS graph. So that's how DFS graph is working, and these are the applications of the DFS graph. So DFS graph, time complexity is V into E or V plus E, depending on the structure of graph. If it is a complete graph, then it requires a maximum, that is worst case scenario. And if it is a normal graph, then V plus E. Otherwise, or likewise, there are other graphs also like topological sorting, BFS, and these three have the same time complexity, that is V plus E, that is vertex plus edges. So in graph, what is vertex and what is edge? So vertex is a point literally, and edges are the line between those two vertices. And it, by combining vertices and edges, we create a tree, that is a graph. And when we traverse that graph in the principle of LIFO, then we called it that graph as a DFS. And when we called it BFS, when we traverse it through the FIFO principle. So that's the most important difference between the two graphs. So that's it about DFS graph. Let's see how we can code this graph. So I use here class, that is graph, and in that graph we have to first make it public, and in that we have to define one vector, because we can't just do it by using arrays, because it requires a lot of functionaries to add the elements and then revisit the elements. So that's why we are using here vectors. So then we have to create a function visited, function. We are just declaring, and afterwards we have to define them. Then map int list int, and then add, that we called as adject. These are two vectors we are created to do the functions of adding the points and then traversing through the points and then printing the points. Then we require another function, that is add edge, and it takes two parameters, that is vertex as well as weight. Means how much distance the one vertex is from the another vertex, that is the weight of that vertex from the root, if you consider. And then we require another function, that is Dfs, and in that we only take the vertex, and that's it. This is our class, which takes two map vectors, and according to that we are created two functions, that is add edge, which take the edge and add it to the graph, and then Dfs, which traverse the graph. So we have to use scope resolution to define the graph. So add edge int v comma int w, and in that we require vertex dot pushback method, which takes the weight and add it to the graph. So add w to v's call. When v is called, the weight is added to the map function. That's it. This is a void graph function. So another function we require, which is Dfs. This is our main function, where we take the vertex and follow the LIFO principle and do it according to that. So we require here visited. If we visited that vertex, that is v, which is if I assign as to be true, then we simply print out that vertex. Means we are visited that vertex, so we have to print that vertex. This is like something similar to the head regression. We have to first conditionalize that particular statement, and then afterwards we have to work on that. So after that, recursively for all the vertices adjacent to that, then to this vertex, that is we require list int and then one iterator. Iterator is like which can be taken object of that list, which can be mapped to that. So that's why we take iterator. So we require here one for loop, which is I is equal to add of v dot begin function. Means we are beginning from this point, then I not equal to adjoint of v dot end and I plus plus. That's it. So after that, if that node is not visited, that node means that vertex is not visited, then we have to call Dfs function. So this is what we do. First we create a vector, list vector, and that is of type int, and we choose iterator, that is I. Iterator is something like the object of that list basically, which can have a blueprint of the list as a type int. So we are starting from the beginning of that vectors, or sorry, the graph of ADJ, which we are written over here, and until it is not end, we are traveling through the visited list, and if it is truly visited, then we here print that is where it is, here it is. We just print that if it is true, then we print the vertex, and if it is not, then we created the list, and we call the DFS function again. So it is like recursive call, it is head recursion. So that's it. So let's take the, so this is class and this is object of that class, and we have to add the edge, that is 0 comma 1 g comma add the edge 0 comma 2 g add the edge, that is 1 comma 2, then g comma again add the edge which is 2 comma 0. This is all vertices and respective weights of that vertices. Like 0 comma 1 means visualize the two-dimensional graph, that sorry, two-dimensional array, and that is 0 means a first array in that first element, and then 0 comma 2 means zeroth means first array in that second element. Likewise, we are adding the elements to its respective position, because we visualize a tree but we cannot use a data structure which can be actually create a tree. We have to use an array to do this. So that's why we are adding the edges. So g dot, again we have to add another edge, then g dot another edge. So that's it, these are sufficient one. After that, we have to here is the DFS traversal. We have to call DFS function, that is DFS of 2, means our root node is 2. So g dot DFS, and that's it, code is ready. So just have a look if any have any errors. So expected column, okay. So this is a class, so it is expected semicolon. So that's it. So code is ready, saving and running it in front of you. Let's see what we get after doing this. We should get 2013 as our output, because we are putting edges as 0 to 1, then 2 and 3 likewise. So that's it, 2013 means we are getting correct output. So that's it, this is code. Stay tuned, like, share, subscribe if you like my efforts. Stay blessed. Thank you.